Assalamualaikum. My name is Ahmad Nurfaihi Rizalman. I'm from University Malaysia Sabah. My presentation today is strength, characteristics, and temperature distribution of concrete containing crumb rubber as partial replacement of fine aggregate. There are many research has been done to find the application of rubber in concrete. Many research discover that rubber improve ductility, toughness, impact resistance, and fracture and damping of concrete. However, rubber reduce compressive and flexural strength of concrete. In addition, greater strength loss was found when coarse aggregate are replaced with rubber rather than fine aggregate. Although the use of crumb rubber as partial replacement of fine aggregate in concrete still reduced the strength, it met the minimum strength requirement of lightweight aggregate. For research problem, despite many studies on the mechanical and dynamic properties of concrete containing tire rubber, the knowledge on the fire performance of concrete containing tire rubber is not widely explored. To solve the research problem, the following objectives are outlined. First objective is to investigate the strength characteristics of concrete containing crumb rubber, and for the second objective, to investigate the temperature distribution of concrete containing crumb rubber. For the scope of research for objective 1, the concrete mixes followed the standard specification for building work JKR 2005. The type of concrete mixes is group 25P and group 30P. And then for group 25P, the water cement ratio is 0.5 and the cement content is 9.54 kg per meter cube. And for group 30P, water cement ratio is 0.45 and the cement content is 10.65 kg per meter cube. For the percentage of crumb rubber replacement, there are 3%, 5%, 10%, and 5% by weight. Therefore, the total specimens were 10 specimens with average of 3 readings. For the scope of research for objective 2, the type of concrete mixes only one, which is group 25P, and the water cement ratio is 0.5. Cement content is 9.54 kg per meter cube, and for the specimens, there are two. The first one is plain concrete, and the second one is 10% crumb rubber replacement. For the materials used in this research, the cement used was ordinary Portland cement STM type 1, and for the crumb rubber, it was obtained from Hoyo Tire, Sel Sendirian Berhad. So table 1 shows the physical properties of coarse aggregate, fine aggregate, and crumb rubber, which shows the difference in terms of the sizes, moisture content, and water absorption. For the test methods, to investigate the strength characteristics, the specimen size for the concrete cube is 100 times 100 and 100 millimeter, and for the concrete prism, the size is 100 millimeter times 100 millimeter times 500 millimeter. There were 3 testings for objective 1. The first one is slump test, compressive strength test, and flexural strength test. All of these tests followed the British standard testing. And then for the test method to investigate the temperature distribution, the specimen size is 420 times 130 times 200 millimeter. And for the testing, as shown in figure 2, after the 28 days of curing, the concrete block was exposed to fire for 30 minutes, and then the temperature was measured at 3 points shown in figure 1 using thermometer. Alright. Result and discussion for objective 1. The result for slump test is shown in figure 3. It was observed that the results are consistent with a constantly decreasing trend as the percentage replacement of crumb rubber increases. There was a huge drop in slump height in 5% of crumb rubber for both concrete 25P and 30P. The reduction in slump height was due to the rough surface of the crumb rubber particles as shown in figure 4. The increased amount of crumb rubber in concrete increases the friction between rubber and the other particles. The compressive strength comparison between concrete 25P and 30P is shown in figure 5. It was observed that a decreasing trend in compressive strength was observed with the increased percentage replacement of crumb rubber for both concrete. The reduction of compressive strength was due to rubber particles are poorly bonded with the cement base, therefore resulted a gap between them. Figure 6 shows the image enhancement of plain concrete and concrete containing crumb rubber under SEM. It was observed that the plain concrete shows well-bonded particles, but crumb rubber concrete shows a poorly bonded with the cement paste, which resulted a gap between these two particles. The flexural strength comparison between concrete 25P and 30P is shown in figure 7. It shows that the flexural strength decreases as the replacement percentage of crumb rubber increases. Unlike compressive strength, the differences in flexural strength between concrete 25P and 30P also become smaller as more crumb rubber are added to the concrete. For the result and discussion for objective 2, the temperature measurement between plain concrete and concrete containing crumb rubber at 3 points A, B, and C are tabulated in table 4. It shows that the concrete containing crumb rubber has higher temperature than plain concrete. Therefore, this suggests that concrete with crumb rubber is not suitable to be used in area of high fire risk. For conclusion, for objective 1, slump height, compressive strength, and flexural strength of concrete reduce as the percentage of crumb rubber as fine aggregate replacement increase. And the reduction in the properties of concrete containing crumb rubber was due to the rough texture of crumb rubber and poor bond of the rubber particles with the cement paste. Conclusion for objective 2, higher temperature were observed in concrete containing crumb rubber than plain concrete when exposed to fire. However, it is recommended that fire test is to be conducted in closed environment to ensure constant and repeated fire exposure on the concrete. In addition, the effect of varying amount of crumb rubber on the temperature of concrete in fire is to be investigated in the future. For the acknowledgement, the authors would like to thank University Malaysia Sabah for granting this project under code UMS Grade GUG 03461 2019. Thank you for listening.